All right, thank you. This actually will be the last time we probably record under this set of tooling anyway. It's on the agenda for a little bit later, but we are going to try to transition the TST meeting to the LF tooling for next week, and we'll get to that, I think, a little bit later on the agenda. But I thought for starters, I wanted to spend a couple of minutes because the results are really impressive and I think important to what we're doing. And let Bilal give us an overview of what he and others have been doing to scale the SD core. And Bilal, you want to grab the screen?
Yeah, I would like to share a screen. Yeah.
Go ahead. We're just going to spend a few minutes on it, and we'll probably come back later and spend more time, but I wanted to give everyone a preview.
Okay, can you guys see my screen?
Yep.
Okay. So hello, everyone. My name is Bilal. I'm a PhD student at Purdue. I'm working with Professor Shabazz, Professor Larry, and we are collaborating with Ajay Thakur at Intel. Right now, we are working on scalable Ether design. So first of all, I would like to give you an insight that we have identified so far, that there are multiple kinds of pods in Ether. Some of them are stateful, for example, AMF and SMF. They maintain a very persistent state of each UE-related information in their own pod. And then there are some state-led network functions, for example, UDM, UDR. They just talk to other network functions, get the state, get the response, and send it back to the other network functions. And then we have the DB, where the persistent storage, for example, any UE-related information, TIMCs or IMCs, that kind of information is stored out, policy control rules and stuff like that. So these are the three main patterns that we have identified. And for in each AMF, there's a different pattern as well. There's a long running row routine running for each UE. In SMF, it is not that kind of pattern. It is a for each request, you make a row routine, you process it, and you just send the response back or send it to the any other network functions. So to make the Ether more scalable, first we need to remove this statefulness of the pods. First, we need to make them stateless so that they can be scaled based on the needs of traffic. So one thing is that we need to make this state stateless. So we need to shift the state somewhere, either in DB or somewhere else. For our evaluations, we made this state stored in a Redis DB in an asynchronous manner. So for example, when a request comes in, AMF processes it and updates its state, as well as asynchronously update and write the state to the Redis DB as well. So in case any other pod comes in, or the request goes, AMF dies, or another AMF comes in, and the request goes to that AMF. If it does not have the state of the UE, it looks up its cache, it doesn't find it, it fetches from the DB and processes the request, and it does not respond in a failure. For SMF, we have to additionally do one more thing. Let me go to the next state. So we make the AMF and SMF stateless in this manner. One thing we had to additionally do to make the SMF stateless is that we had to modify UPF as well. I guess Ajay might have updated you in that manner, that UPF was maintaining state of the UEs associated with one SMF. If that SMF dies, it just removes all the sessions associated with it. So we had kind of moved, updated or add a spot in UPF to handle multiple SMFs, so that when SMF dies, it does not just remove all this context of the UEs. If another SMF comes in and it is looking for a UE with a reference, and then it finds in its local cache, it just associate that previous stored session with the newly created SMF. So to make so we modified UPF. So we made SMF and AMF stateless, and then as we can now have multiple AMFs, so we kind of need a load balancer before AMF, so that the traffic can be distributed among AMF equally. So for that, we introduced SETP-LB, where all the GNode SIMs or the RAN towers ends their connection for SETP-LB. Then SETP-LB does the two jobs. That one, it gives the RAN one single interface for SETP-LB, and then we distribute the traffic among the AMFs. according to the load. So for load balancing, we are just simply relying on very minimum load logic, so that for each network functions, how many UEs it is handling. For example, SCTP keeps track how much traffic each EMF is handling. And then based on those, if a new UE comes in, SCTP will send the new UE request to the EMF with a minimum load on it. And when SCTP-LB assigns one EMF to one UE, it makes it persistently, like, so all the subsequent requests of those UEs will go to that EMF, so that it does not need to fetch the state every time from the UE, so that it has the cache associated with that UE in its state already, to make it more efficient. And plus, for the rest of the network functions, the load balancing technique that we employ is the similar, that whenever a new request comes in, a new UE comes into the network function, it updates it, say that I'm handling that many UEs, and it consistently updates its the number of UEs it's handling to the NRF as a load the parameter. So when any other network function needs to decide which network function I pick, it fetches all the latest number of network functions from NRF, and based on the load, it picks up the minimum one. So all this load balancing is happening on this min load logic so far. And so far, the design of the Ether that looks like is something like this, that all G-node-based systems are connecting to SCTP-LB. SCTP is maintaining or load balancing between AMFs, and the rest of the network functions have multiple copies, and they are doing the load balancing based on the min load logic. Then SMF is directly connecting to UPF, and UPF can switch context between newly created SMFs and previously destroyed. So based on these design that we have implemented, we have some evaluations where first of all, we measure 3 different events: registration, PDU, session establishment, and service request. So what we do is that we send a traffic in a bursty manner, and we send for example, we start sending traffic from 256 UEs, and they all send traffic in a burst, like they start immediately together, and they send back-to-back traffic so that we can rigorously test the system under high load. So back-to-back, it's a closed loop system. The one UE sends a request and waits for the response, and then sends the next request. But they send it back-to-back 100 times. So each UE sends 100 requests back-to-back. So in this case, if you can see for the registration, as we increase the load, the latency goes up for the Ether as well. The blue bar, but as compared to Ether plus 1 means there's only one pod of each network function. Ether plus 2 means there are 2 pods of each network function, 2 AMF, 2 SMF, 2 UDM, and 2 UDR. And 4 pod means there are 4 instances of each network function already scaled from the beginning of the experiment, just to get the most benefit of having multiple pods or scalable design. As you can see, as we increase the number of pods, we see that the latency goes down drastically as compared to vanilla Ether that is performing in this way. So we also had tested, so this is a synthetic trace where we dedicatedly send back-to-back 100 requests with a 10 millisecond delay. We also found traces in real-world traffic that the delay between 2 requests, how do they exist in the real world. So we use that data, and we send the traffic based on those real-world traffic. As you can see, for the real-world traffic, the margin estimate for Ether plus with 4 pods and with vanilla Ether is quite high. Same trend we get for the PDU session establishment, where SMF and AMF are the main bottleneck. And for the service request as well, that is more the frequent event that you experience in the 5G world. To make it more realistically, to test it in a realistic scenario, here I'm showing you the auto-scaling or horizontal pod auto-scaling feature of the Kubernetes, where based on some load, like Kubernetes automatically spins up more pods. For this experiment, we are using a CPU as a threshold to spin up more pods. Later on, this is a new direction where we need to identify which exact measure should we use to scale up more pods. But for this experiment, we are just using simple CPU as a measurement to spin up more pods. So for this experiment, we start adding more UEs linearly into the system. After 1 second, we add 1 more UE, and that UE continuously keeps sending the packet over the span of time of 6 minutes. So after 1 second, a new UE comes in, mimicking the load is increasing on the system. As you can see, the ether linearly goes up and up and up. And after 4.5 minutes, all the UEs, 250 UEs have been added to the system, and the latency becomes straight to the straight line. But as soon as the load is increasing, the latency is going up linear. But on the other hand, if you see on the Ether Plus, we call it our design Ether Plus, but you see that initially we see some higher latency because of the load balancing, the SCTPLB, and storing the state into the DB. But as you see, as the more pods are coming in, now the traffic is being divided between two pods. Till here, there was only one. Till here, there was only one AMF. At this point, two AMFs came in, and all the subsequent new UEs that are coming into the system are being redirected to the AMF2. So the overall latency of the system is going down. So as still here, there are two AMFs, but the system, the new UEs are coming in. So both of the AMFs are now handling the same amount of traffic to here. So the latency starts going up. But here, as the new AMF comes in, like 3 and SMF as well, the latency starts going down because all the next subsequent UEs are being again redistributed to the newly created AMF and SMF. But here, until this point, we limit the maximum number of pods that can come into the system to the 5 because of the system resources. So after that, all the UEs that are coming in are equally being distributed among all the pods. So the latency does increase linearly a little bit, but not as compared to the vanilla either. If we have more resources, the more pods would have been come in, it would have never gone up like this. It would have stayed here similar to like this in this line. So yeah. So, but it does give better performance, like 3x better performance as compared to vanilla Ether that we have in the system. One more thing that we have done is to increase the resilience of the system. So for right now, Ether does not have, if SMF, like for any of the pod fails, then the vanilla Ether stops responding. The UE has to has to resend the event again from the scratch, from the registration and stuff like that. But we added a support into the Ether Plus that if one of the pod fails, you should not immediately send response in a failure, but should wait and for the next pod to come in and continue sending response from that one. So in case of for this experiment, we killed or we deleted the SMF pod using the delete command. As you can see, vanilla Ether just stops responding to the request. But in case of Ether Plus with one SMF, there is a gap before because there is like a new pod is coming in. When it comes in, it starts responding back. But in case of two SMF, because there's already a warm up state instance available, AMF quickly picks up the newly available SMF and starts to responding to the request immediately. So that's what we have done so far for the scalable Ether design and plus implementation that we have.
Thanks. Quick questions. I don't want to burn the whole TST meeting on this, but are there any quick questions we could? Maybe AG, is that your hand up?
Oh, no, I was giving reaction. It's great work. Yeah.
Oh, okay. You were giving a thumbs up. Thanks. Yeah, this is really fantastic to have these results.
I do have a question. So I was curious about, you mentioned latency multiple times here. What is this latency between what and what? Because the AMF is not in the user plane path, so why does scaling it impact any form of latency?
So the latency that I say is the end-to-end latency when the GNode-based SIM sent a request and it got the response back. So this is the latency of the 5G core, the time it took to process through all the pods and got the response back on the GNode-based SIM side.
Another part of the answer here, I think, though, is that in an IoT workload, one would expect a lot of registrations relative to the data that's flowing. So this is control plane latency as well.
Yes.
Okay, so it's like a user would experience this on the first time setup, but not as they use their application.
Yeah, this is control plane. Yes, correct. Yes. Correct.
So that, as an example, what we're showing there is registrations and then PDU setup.
Yes.
So that's the full end-to-end, you know, this is just the initial attach. This is the data channel being, you know, set up with the TEIDs and all that good sort of stuff. So yeah, that it definitely makes sense. And what you were saying about the SMF being a bit of a bottleneck there, I get it as well.
Yes, that is correct. Yeah, thank you.
Yeah, I was initially surprised to see that you were going with a custom load balancer for the SCTP until you explained that it was for session stickiness.
Yeah.
Was there anything like using the platform load balancer, like a Kubernetes one, or that was just?
So there are multiple reasons. So for example, if you do load balancing based on service, so what happens is that you don't have control over that load balancing. So we want stickiness due to multiple reasons. One thing is that, so if the request goes into the wrong, and I won't say wrong, but not associated to the network function that it went to previously, it won't have the state in it automatically already. What it's going to do is that it's going to go to the DB, fetch the state, and comes back in. That's performance hit. Plus, what happens is that we can experience that two subsequent requests from the same UE coming in. For example, in service request or after security context, you can see another packet coming in from the same UE. So what would happen is that one packet, one request would go to one network function. Let's say AMF1, and another one goes to AMF2. So they are now being processed equally, or not being processed in parallel. What's going to happen is that AMF going to update the state in some based on that request 1, and AMF2 is going to update the state based on request 2. So now there is going to be an inconsistent state for the same UE into the system. So subsequent requests might face inconsistent and might see some failures. So for example, registration went to AMF1. That's fine. But this PDU is now coming to AMF2, and the service request, subsequent service request is coming to AMF, is going to go to AMF1, let's say. But now it's going to make the system inconsistent. Either what we do every time when a request comes in, we fetch the state from the DB. That's going to cost you again for each request that you're storing and getting the state or updating your cache. Or the better way that we found is that, so in this approach, we also tested that we read the state from DB for every request. That adds up to 30 milliseconds on average per request. So the optimal design is that you cache and then you stick it to the same AMF or same network function, and then you get better performance.
Thanks. I'm going to cap the discussion here because we do have other things on the agenda, but this has been fantastic, and everyone should feel free to follow up with Law if you have additional questions. Okay, thanks. So let's move along. Looks like Gabriel has an item here on SD-WAN contributors. This is one that came up before, and I guess this is a call for who are these contributors? Is that right?
Kind of like that, yes. So let's say if we receive some request from somebody related to SD-WAN, so who should we direct these individuals to, or it's more from that perspective, and also if they need additional support or something like that.
Unfortunately, there's really only one good answer today. Does anyone have anyone else to add to this list?
Well, there is a body of work that's going on kind of on the RAN side that isn't really cross-populating into here. And, Larry, that's, maybe Alex, possibly. And,
so I'm absolutely, that would be fantastic. I don't know. I can't see if Alex is on. We have to have a situation though that someone submits a PR and Alex. I mean, there certainly is this parallel activity, but is it deep enough in the guts of SD-WAN as opposed to building on SD-WAN to be responsive? And I don't know the answer to that.
Yeah, that is the right question. I don't know what, Alex, can you say anything about that?
Yeah, so from deep dive in the code, I'm not that familiar with it. So as compared to Wujong. Yeah.
So in this case, does Wujong know that he's going to help provide support?
Yeah. He has been very responsive. We don't necessarily see it here, but he's been responsive to the whole body of work that Alex is involved in. So, I don't know that there's a problem. He definitely has been responsive when he's been asked to.
Okay. Yeah, there was somebody, I believe from Brazil, was asking me something related to the KPM service model, some type of pickup for the E2 setup requests. I didn't have a chance to kind of deploy the whole setup. I have been pretty busy with the SD core itself. So he was kind of like desperate, trying to contact multiple people to see who can help them. So who can help him. So that's what I was kind of curious to see.
Yeah, I think unfortunately today Wujong is the the right answer and an indefinite bottleneck choke point in what we're doing. And I think that what's going on, I mean, what Wujong's helping Alex and others do is to make improvements into RANSEM, and he's been very much involved in that. That is going to bring more people in, and then we can fix this. But I don't know how to do it except organically. But so the short answer to your question is Wujong is the right place, and if he's not responsive, then we'll have to figure something else out.
Okay, thanks.
And I'd just say too, I don't know, Alex, if you know if Ramido is in a position to become more active here, because they're kind of reliant on it. This is a company in Europe who's been using and writing X apps and R apps.
How do you spell that again?
RIMEDO.
Remido Lab, yeah. Because this is also the question we face right inside Intel. We are doing a lot of XApp development. I mean, some other groups, some peer groups, right? And again, it's what's the status, what's the health of the rig, right? As they compare to the OSC rig and other rig, right? And if this one goes too far beyond, very quickly, all this XApp work will move to other rigs, right? Other platforms.
Yeah, no, Christian, you're right. I think there's kind of a line of activity to maybe have a discussion in this community and kind of an honest discussion about it. What's the level of enthusiasm to continue to kind of support and advance it?
Right,
and I think
to maintain and advance.
Some of the service models are getting dated, and and I don't know the answer, but.
So maybe one thing to go back to Wujong with is can he help us grow this set and make that be the ask in a sense of who he knows that might be.
When you say the set, you mean the set of contributors?
Yeah.
I think that the person who can probably help us there is Surat as well. And Surat's not a developer, but he is kind of driving this community on the RAND side. And for those of you who don't know, Surat is the PI on the NTIA grant that the Aether project, received, and that works going towards energy savings, kind of low down in the RAND side. But it is, a source of investment, and the plan is to build a stack that is using, the SD-RAN work. So, kind of comes together there, and Surat is driving that community.
So, I mean, one thing that we can actively do, back to Gabriel's original question, is include Surat and Alex, I would say for right now, in any response so that they are at least tuned into the activity, even if they aren't able to answer the question immediately. Kind of a poke that there's stuff going on here you need to pay attention to.
Yeah, no, I think that's good. And Alex, I think it's great that you're here as well. I didn't see that you had joined. So I think that, this is the first step in this kind of cross-pollination.
Yeah, oops. What I was just going to annotate on Alex there just for completeness is it would be great to include in, CC when responding. so that he's in the loop on those as well. Okay, Gabriel, core release.
Yeah, I was kind of just wondering, whether we can define some type of target date for the SD core next release. And regarding the second point, support from DAF, we started kind of like a weekly meetings last Thursday, Agile and DAF to kind of try to address specific issues so we can keep moving forward in a speedy way on this.
Good. So what specifically is the support from DAF?
Oh, so for example, in this specific case, there are a few things that we are not able to do it ourselves due to the limited access into, let's say, repositories. For example, configuration of the secrets. We are now in the process to try to use a FOSA action that doesn't actually expose the token directly and use it as a secret. But at the moment, we're facing some issues that for some reason that action works in my personal fork, but it doesn't work in the OMIC project itself. So those kind of things that we are not, we don't have capability to kind of access that level.
Thanks. Yeah, so I think very concretely, it would be good to see, let me just call it a roadmap. And just as a reminder, we currently have this folder. It would be great to put a SD core roadmap file in there. Again, we're going to change to some different tooling, but just to point that as a first stop. So presumably there's going to be a wiki here any day now, and that would be the right place to go. And it'd be good to spend time in this TST call with that roadmap in front of us so that we can comment on it and beat it into shape.
Yeah, Larry, roadmap, and along with the roadmap, maybe the SD core capabilities, right? We talked about it, I think, last week, right? Which feature for which release do we have, and
Yeah. And when does it get released? Yeah, exactly.
So let me just, on this topic, other projects, start with a release cadence, and then it's kind of what features make the train. What I'm hearing here is more like, a roadmap, a more conventional features are driving releases. Is there benefit to thinking of it the other way and just doing, whatever it is, 4-month, 6-month cadence releases?
I think doing it once in a 6 months sounds good. And if the release has some purpose, some big feature, something coming in, then that makes it better, rather than just fixing the bugs, right? I think we can keep fixing the bugs or small features, but we should always target at least one big feature in a major releases. And then that's what I can think of here.
Yeah,
and if we have many more contributors, we can have it quarterly.
Right.
That we could even have a conversation about cadence.
Yeah,
is a good development.
Yeah, after it will be based
It
on
implies there will be another release at some point. So what I would propose here is that we just get some initial thoughts down on what the features, when they'll be ready, and the very earliest sketch of what would go on in initial release and when that would be and what would go on a follow-on release, so that we can start to delineate between immediate goals and future features.
Yeah.
And I will come back and prod you on that, and it's a little bit of we're waiting on some tooling to get in place. Once we have the wiki, I think it's going to be obvious where these things get written down, I hope. Okay, Gabriel, another issue on
I was
yeah.
just going to pipe in here for just a moment.
Please.
I know Linux Foundation has release managers and processes defined for other projects. And I'm wondering if that's something that is being looked into in terms of process change heading towards releases.
Well, when you say managers, I mean, I'm going to say DAF might actually be that person.
Yeah, probably.
Yeah.
I can't get to my mute. Can you hear me?
Yeah.
Yes.
Okay. Yeah, that's the expectation as we go forward. That's the services being provided by by myself as part of the team shift here.
Okay. So who then comes up with, I mean, there's one thing to actually do the release process, the packaging, everything like that. Is there an overall process in terms of release readiness? Content of the release, what goes into it, milestones, release slippage, like dates, that sort of stuff. Is that something that's been?
That is I'm bunching all that, packaging all that up and calling it the roadmap. But yes, that we do not have that. That is what we need to start writing down.
Yeah.
Okay, perfect.
In case the second question behind it, I don't understand, but that is what LF expects the TST to provide.
Yeah. So the second part was in terms of slippage of dates. So say we decide that we're going to release every 6 months. So that means the next one, say, is in August. And as we're getting closer to August, what's our level of confidence that we will meet that release? Those are the sort of things that I mean by date slippage or project readiness. How do we know that the project is ready to be released? So, yeah, a set of milestones, essentially.
Yeah.
Effectively,
let's make it as a goal by next TST to have at least established draft 0.001 of this so that we can have a place to go write these things down that's a little bit more firm than these notes.
And who's responsible for making that draft?
Well, I think AJ is the starting point. But we need we need the tooling. We're waiting on. We could preliminarily do that in one of these, start a doc here, but we're waiting on the wiki as a place to write it down.
I would think we'd want to be careful to not let the tooling be the blocker. Hopefully it'll all come fast, but.
Well, right. So Daph, I thought this was supposed to be here. So what are we blocked on the wiki? Do you know?
Are we talking about the existing SD Core wiki or an LF?
No, we're talking about a new Aether wiki that is set up under LF's.
Okay. What we're blocked on there is a domain change that I'll be starting today. We tried to start that yesterday, but it wasn't quite ready background. Once the request is made, it'll take 5 to 7 days to set up the registered domain change, at which point we can move the wiki contents to the new LF posted site.
All right, so I don't want to. I agree with Timon. We don't want to be blocked on that. I will create a doc since I'm able to do that, and then I will make it available in that folder. And I believe AJ and Gabriel probably have the immediate set of. At least let's start with listing the features so we know what those are.
Okay.
I think the features would be the right thing to list, and then we can start prioritizing them and putting dates on them and so on. Does that sound okay?
Yeah, and I think we can get some draft ready in next TXT. Yeah.
Okay, so let's make that a goal. Okay. Thanks. Okay, so Helm charts.
Yeah, so it's not just the Helm charts, but the SD core. So we already have the Helm charts and the docs, the documentation in GitHub. We are kind of planning to start. I already have a PR open for the Helm charts to address some minor things, and then I need to kind of open a couple more PRs that I have pending. But the thing is that, and also Suresh has already some a PR to be open for the SD core docs. What we need here is to make sure that we have the whole automation in place, such that when a new change in the SD core docs is done, to make sure that that is actually reflected on the documentation itself.
Yeah, so I just related. Couple points down. Oh, I'm sorry. It's maybe one of the 2 points down. I have now replicated Aether docs in GitHub and I don't have it going live, but I have an action that will publish the docs to the web page. So once I have that, we can mimic that then with the other docs.
Okay, so you have a GitHub action already in place, or
yeah,
kind of...
I have a GitHub action. So what I have done, let me just go ahead and jump ahead to that since it's relevant. Well, I won't jump into it. There's an Aether docs in GitHub that is a copy of a fork of what was in Garrett. And I have defined an action that runs anytime you push an update to it to publish, to build the docs and push them to the web server.
Okay. Yeah,
and
we
I
should
will
do something similar.
Yeah, I was playing a little sandbox, and I've just now started the process of moving it into Aether docs. And once that's working in the next day or two, it should be live, and then you can look at it and just copy it.
Okay. Thanks. It's a little bit more obscure from the perspective of the Helm charts, how the Helm charts are typically published. Is there some type of Jenkins job doing that?
Yeah, so I think that's an important point to make here. One of the options that I faced with Aether docs as I was trying to do it was there is already a Jenkins jobs that publish the docs, and I could have pointed it at the GitHub repo instead of a Garrett repo.
Right.
And that is an option. Unfortunately, in the case of docs, there's something else broken right now. And in lieu of fixing that problem, it was easier just to put the whole publishing machinery in GitHub. That doesn't apply to Helm charts. That I don't know that. I think that's actually a very different situation. The docs are quite a bit simpler.
Okay.
So I think probably the right thing to do with Helm charts is to figure out how to point the Jenkins job at GitHub instead of pointing it at Garrett, but keep the same Jenkins job, at least for the time being. Okay. And this gets kind of to the point that came up in the discussion, and I now forget who all was commenting on. I guess it was just Sean. That version update publishing machinery is non-trivial. So it's not a simple task to replicate it in an action. I'm not sure what all is involved.
Okay.
So FASA.
Do you want to go or do you want
go ahead?
Essentially, we're trying to do a FASA action. That's the formal FASA screen for GitHub Actions. We've defined GitHub secrets that have the FASA tokens at the org and repo level in our tree. The action is not reading them properly, and it's coming out blank. This is particularly strange because Gabriel has been able to define it in his local repository, and everything worked nice and clean. But we're doing the exact same thing in the OMIC organization, but they don't work well. We've got a touch in with FASA, who's already replied to us saying they think it should work, but we'll be devising more into it. But until we get that resolved, the question is, do we stop, just delete the FOSSA status check so they don't get run at all to get people working? Or do we hard code the secrets into the code base? Hard coding the secrets is not horrible because the secrets are push only tokens, and the only thing it affects is throwing data at FOSSA. It doesn't affect FOSSA internally or our code. Does that make sense?
So probably for now, the easiest way to go is to kind of stay with the previous FOSSA action, the one that we have the token in the in the action itself.
Okay.
But the only thing is that that's going to trigger lots of PRs that need to be open. Is there any, I don't know, objection or any way that we can just create a new token in FOSSA, new push only token API, and manually kind of like update that without having to go through the PR process? That's going to make things simpler, and we don't have to disable the FOSSA check itself.
I am not aware, because we need to change. We need to either use a brand new token or use the value from the existing token. In either of those two cases, you have to update the GitHub action, which
Correct.
is defined in each repo.
Correct.
Right. So
Yeah.
I don't know any way other than that. The only thing I can do is disable the action or update all the actions in all the repos.
No. What I'm saying is for now we have all the branches protected, right? So basically, they only accept a new code or changes through pull requests. What I'm saying is whether we can avoid the pull request, at least just to kind of paste this new token to avoid the whole PR process just for this specific case, and then re-enable the branch protection. So I don't know what everybody thinks about this. Otherwise, we need to kind of start opening one PR for each of the repos, and then start approving them, merging them. So that's what I'm kind of asking. What is the opinion?
Yeah, that's to the group.
I don't know that we have an informed opinion on this either. I think in this case, leave it to you and DAF.
Okay.
Okay.
Okay. Let's do this.
In terms of having an informed opinion, I don't think there is one.
Okay. Okay. So let's chat after the meeting, DAF, if you have some time.
Yep.
So we can try to address this.
Okay. We've already hit the docs. I just wanted to highlight that we do have a choice to make on every one of these kinds of decisions, which is to write a new GitHub action from scratch that mimics what happened on the Jenkins CI job, or point the existing CI job at a different repo, the GitHub repo instead of the Gerrit repo, but otherwise keep it running as a Jenkins job. In the docs case, it was straightforward enough to just replicate the action in Git as a Git action. But we need to be cognizant of that as we take care of these in each case. Moving future TST meetings to LF tools, I don't have any specifics. Michelle, who will provide operational support for Aether, is starting to shut down old ONF Zoom accounts, and wanted to know if it was time to shut this one down. I told her not today, but let's try to make that change by next week. The best thing to do, this is probably the most critical point, is watch Slack TST channel for updates. I don't know how else to keep everyone informed of that. Except this page, which maybe you go to because it has all these links in it. What I will update this page as well.
I guess there would be an updated calendar invite anyway if it changed from Zoom to something else.
Yeah, watch this page for updates and watch for a new calendar. I just don't know where you're gonna see that calendar event is the problem. But between those three things, hopefully we've got enough replication that you will all find your way back here next week. Okay, there's an issue on the core wiki.
Yes, so unfortunately Suresh was not able to join today. So as I mentioned earlier, he's preparing a PR to update the documentation to primarily indicate how to deploy the UPF in DPDK mode when using either Eating in a Box or on RAP, right? When he has the PR ready, but when he was doing his testing, he basically, one of the checks that currently happen is to make sure that all the links are still alive. All the links in the documentation are still alive. So he was seeing this issue with the wiki. So yesterday morning we had a call and he was having that issue. Then I talked to Daf. The wiki was up and running when I talked to Daf, but early today I check again the wiki and it seems to be down now.
This is the ONF wiki, right?
Say it one more time, please.
This is the ONF wiki that's the problem, right?
Yes, so basically the SD core that opennetworking.org.
Yeah, so depending on the ONF wiki long term is probably not a good thing. So the other option is to mark, I don't know how to say this, is to mark ONF wiki as an exception. I don't know, ignore.
Let me ask a little more. So, I mean, to my knowledge, I'm not aware of an SD core wiki. If we could get a URL in here, I think what Larry is saying is there is an open. Go ahead.
There was a wiki, right? I think, but it went down, and then we decided not to bring it up, or like just.
Well, SD Core Wiki is a sub piece under ONF Wiki.
Correct.
So it's actually available just because Wiki is up.
So this arguably is a hack, but I'm noting that the other option is to just ignore that wiki until we have wikis we can depend on, and we're in a transitional state right now that I don't want to have block us.
So then from that perspective would be to ignore it then at the moment, right? So otherwise we wouldn't, the test is not gonna pass and we shouldn't be able to kind of merge that.
Do you know what I mean? I'm pretty sure it's in conf.py. There's a little block that lets you ignore URLs that get tested by that dead URL link testing tool.
Okay. Okay, thanks. Yeah.
And it's a hack, but I think this is totally legit in the state that we're in right now.
Yeah, that's fine, but we just need to remember later on to kind of.
So later on, we will continue to ignore the ONF wiki because there will be an Ether wiki, and then you can.
Well, yeah, later on we need to kind of.
And then you'll need to go change all the links. Yeah.
Correct. Yes.
Yeah. Let me just actually note that until we update docs with links to the Ether wiki, which will have an SD core whole tree to it. Okay, QA status.
Yes, Larry. Yeah. So I'll start with the first UE failure. We are still trying to figure out where exactly the issue is. I think Ajay, if you have anything on this.
So Kunal, I think the best way is that while we are updating the Helm chart, what best you can do is that just override the images to see if the problem is going away. Because I don't see any point in debugging the code which is probably 6 months old in the Helm chart.
Yeah,
right?
I agree.
Because most of us don't see that issue. Yeah. So you have option of taking the latest images, override it. The minimum is that web console, I think, but that's where we are seeing the problem, right? Web console, and then trying it out at least while we get the Helm chart repo up in the GitHub, and we fix the job where we can start publishing the new Helm charts. Right? So while that happens, manual override is the only option.
So let's deal with it this way. Let's add a new integration test. We've already got default and latest, but this isn't technically latest because latest is the latest Helm chart. This is an integration test that hardwires in the latest. Which core images is it? Was it the SMF? Does this is probably an edit of one of the override files.
Yeah, I think it's web console image is what we are asking him to.
I'm sorry, it's web console?
Yeah, web console.
Thanks. I knew it wasn't SMF.
I mean, I can provide the tag to Kunal. Yeah.
Okay, thanks. Okay, second point.
Yeah. So second point is on IPOF integration to UE ransom. So I think the only I mean, after narrowing down, the only thing which looks like an issue is tunneling through the Docker container. So for Docker container, I have seen a few issues where tunneling through Docker containers was not able to pass through because there was some limitations. So some of the VPN clients were also are also facing on the same the way we are facing on the tunnel interface. So I think that is one of the issues which is causing the tunnel interface to connect to our IPOF server.
So
I think I mean, does anyone think that this is also going to be a concern with GNB SIM also?
Well,
Once
that's why I'm wondering, why does GNB SIM work? And
this is with the Aether on-ramp?
Well, an Aether on-ramp.
Yes.
Yeah, I think Larry, I think I need to, I think you have provided those document links. I need to understand how it works without router pod, because typically we do have router pod in the, when we start the SD core.
So if you go back to Ether in a box, it had two ways to configure the network. One was the router pod,
okay.
the other way was to configure VLANs. And on-ramp uses the second, does not use a pod.
I see. Okay. Yeah, then
and GNB UE ransom is mimicking what GNB SIM did.
I see. Then Kunal, you should try this GNB SIM setup as well, right? To compare what exactly is going on.
Yeah.
I'm sorry,
so in GNB SIM, tunnel interface does not come up.
Yeah, we don't have tunnel interface, but we have the second interface which connects to UPF. Do you have two interface from the UE SIM to SD core, like one as a control plane and one as a user plane, or you have only one interface? I believe it's only one, right?
Yes, only one interface is there.
Yeah.
Is that
Yeah,
right?
I think in the Gnode sim, Larry, the way we do it is that we keep the user plane network completely separate, and control plane is the one which uses the Calico network of the Kubernetes, right? So, and user plane doesn't even go through that. Like it's a plain routing, and there's no Kubernetes routing involved for the user plane at least. So that was easy part to understand in the Gnode sim. And now with the UERAN sim, there is only one interface which goes towards the core, and that same interface is shared for both control as well as data. Right. So
okay, so this is maybe fundamentally what the problem is.
Right.
All right. Well, I mean, this now depends on how UE sim works, and there is another lead because there have been other people that have gotten UE sim to work with core, SD core, set up in the same way we're trying to do on a remote server. So not co-located. I will start a conversation with the people that have done that, and maybe we will find some help there. And I'll follow up with a lead for that. Rock redeployment.
Yeah. For that, I think Sean would be the right, might help us with if there's any findings on it.
This is the same problem we discussed about before Christmas, I think. Canal, is it?
Yes.
Right. I thought the conclusion of that was that it wasn't a problem for you anymore. That was my understanding of it. It's still a problem for you?
Yep. So what we discussed was that this issue occurs when we run an API test against Rock, and if we do not run an API test, we do not see the redeployment issue. So that is something which we have discussed earlier, and I think that I shared with Sean, and I thought he's on.
So the bottom line here is there's no progress. We understand what the problem is. What we don't have is a clean way in the on-ramp deployment to address it. Sean, I don't think there's anything different from what you've talked about before.
No, there's been no progress since. I mean, I had kind of come to the conclusion that this wasn't a blocking issue for Canal, and I haven't really focused on it at all since.
Yeah, I think it's. I don't know that I would contradict that.
Okay.
So I want to just table that and try to do something more rational with it some other time. We need to wrap up because we're over time here, but just what is the last bullet on Jenkins Job Builder, moving it to that? Yeah, go ahead.
Yeah, so as we have created a new repo, Aether Jenkins, for putting all the JJBs to of Aether on ramp view. So what we have seen is there are a few scripts which are there in Aether CI management. So are these scripts are also required in our new Aether Jenkins repo, and is DAV going to do that? Or also you have raised a query that there will it be possible to fetch these JJBs from multiple sources? So because Aether CI management is still there, and one new repo Aether Jenkins has been created. So
well, except Aether Jenkins is only going to build integration tests. So it does not depend, in my view, on any existing CI jobs. It's going to entirely pull down existing Helm charts and existing published images. So in that sense, it's clean slate. There is no counterpart in CI management that I see. And instead of creating those new jobs, so now the question is, maybe I'm misunderstanding. So there are, you said scripts. There could be some dependencies on, I don't know if their scripts are exactly what they are. Is that what you're referring to?
Right.
The other question is, I mean, obviously I haven't touched this and I should have, but do we want to push these scripts in CI via JJB, or should we turn them into actions considering the other movements?
We could turn them into actions. The issue here, and I don't know enough about GitHub Actions, but these actions are going to have to fork off jobs that run in AWS. The default thing that happens in these actions is GitHub runs a container on your behalf.
Mm-hmm.
So this is going to require multiple VMs out in AWS.
That complicates things.
And that just, that would be more work. So having a Jenkins job completely makes sense.
Okay, in which case, effectively what we can easily do is add the JJB structure into Aether Jenkins, new Aether Jenkins repo, and build the jobs using a completely different structure, which is, fully acceptable as well. We just targeted the same thing.
So include the Aether CI management structure, whatever, back all the infrastructure underneath it.
And just add these in. Today's Tuesday. Can we talk tomorrow morning and go over this more explicitly? Was that Kunal?
Sure.
So meet at 7 tonight? Or is that too early for you this time around? I know.
We can meet.
Okay. Let's do that.
All right, thanks.
That's an update.
All right, thanks. All right, we're over. So just thank everyone, and we'll see you again next week. And again, keep your eyes open for a change of detail about how the meeting will come off. Bye-bye.
Great. Thanks, everyone.
Thanks. Bye.
Everyone.
Bye, everybody.